This is one of a series of 6 general revision videos for higher tier GCSE maths. This is based on the revision mats that are available from pixiemaths.co.uk for free, and I'm just going to be working through each of these mats that cover most of the skills needed for higher tier GCSE. So histograms, first of all. Now, histograms is a fairly high level topic. The main thing about histograms is to remember that what is listed on this Y vertical axis is frequency density and not frequency, and that the link is that the area of the chart is related to the frequency, not the height of the bar. So in this one we've got the table, and the histogram shows some information about the cholesterol level in the blood of 100 hospital patients. Use the table to complete the histogram, and then the histogram to complete the table. So in this we will need a column called class width. So I'm going to put class width in here, because frequency density equals frequency divided by class width. Or is proportional to, I should say, but normally it is frequency divided by class width. So class width here, 0 to 2 is 2, 2 to 3 is 1, 3 to 4 is 1, 4 to 5 is 1, 5 to 7 is 2, 7 to 10 is 3. Frequency density, then I'll add an extra column here, which I'll just call FD. Frequency divided by class width, 8 divided by 2 is 4, 13 divided by 1 is 13, 19 divided by 1 is 19, 15 divided by 3 is 5. So hopefully that will tally with what we've got here. I'm hoping to zoom out slightly. So first bar should have a height of 4, and it does, and a width of 2. Second bar I need to add in has a width of 1 and a height of 13 from frequency density. So 10, 11, 12, 13, 15, 14, 13 is in there. Then we've got, whoops, I'll just leave that as it is. Then height of 19 and a width of 1 for this bar. So 15, 16, 17, 18, 19 in here. Put that width of 1, and again that goes in there. Use a ruler in the exam. I don't have that on this software, but yeah, should be straight lines to make sure everything's looking clear. 5 to 7 is written here, and then I've got to put this final one with a height of 5 this time. So 5 is here, and it goes out all the way from 7 to 10 in a single bar. Filling in the table, this one has a height of 17. So the frequency density is 17, and because it only has a width of 1, that also tells me that the frequency is 17. This one has a height of 14, and because it has a width of 2, I'm thinking about the area of this. 2 times 14, that is 28. So actually that's the highest frequency of all, and it looks it because it's the biggest block. As we read it visually, it's got the biggest area, this block. So 2 times 14, 28. So that's how histograms basically work. Okay, capture, recapture. This is a slightly more complicated than usual version of the question, but the principles are the same. So a park ranger wants to estimate the number of fish in a lake. The first thing to do is to say we don't know the number of fish in the lake, so I'm going to call it something out of n, some unknown number. She catches 400 fish. We assume that that 400 is a proportion of all the fish in the lake. She marks them with ink and puts them back in the lake. The next day she catches 60 fish, and 3 of them are marked with ink. So we always assume that 3 out of the 60 that she caught is a representation of, or is proportional to, the 400 out of the unknown number. This is a fairly standard setup up to this point. Then things get a little bit confused with the ranger says there are about 8,000 fish in the lake. Show that she is correct. So normally it would be asking how many fish are there in the lake, give an estimate. And if that was the case, I would be scaling up this fraction so that the 3 becomes 400. So how do I get from 3 to 400? Well, 400 divided by 3 is 133.33. I'd just scale it up that way. Or actually, I would, in this case, 3 out of 60 I can see quite easily goes down to 1/20th, which scales up to times 400, and 20 times 400 is 8,000, and therefore 8,000 fish in the lake. So it's all to do with equivalent fractions. Ranger is correct. Okay, next topic. This is quite quick. Scatter graphs. The scatter graph shows some information about 8 cars and the distance they travel on 1 litre of fuel. So it's comparing the engine size and the distance it will travel on 1 litre. What type of correlation does the scatter graph show? Well, we can see that as engine size increases, the distance travelled decreases. So smaller engine, further distance on 1 litre. If it's a downward slope, that is just a negative correlation, and when it asks for the type, it's just saying positive or negative or no correlation. So we're saying negative correlation is the answer here. We're then asked to make an estimate. A car engine has an engine size of 2.5 litres. Estimate the distance travelled on 1 litre. Now you really want to draw in a line of best fit here, and it should always be a straight line of best fit in maths exams. Sometimes in science, if you're looking at experiments and dots on the line, sometimes there's a curved line. But in maths, when we're looking at correlation, it's always going to be a straight line at GCSE level. So you want a straight line. That's not perfect. It should be probably a little bit lower than that, but it's going to be good enough. Maybe I should do one more attempt. Oh, I can do a straight line. Good. Okay. So something like that. You want to draw that line on, and then you want to show that you've read off the graph. So the best thing to do is to draw your vertical line from what you're reading off, and draw off to the scale. That is about 11.4, 11.3. I think anywhere near 11 will get you the mark for that. It's not going to be exact. So 11.3 kilometers. Anywhere 11 to 11.5 would be fine. Averages from frequency tables. This is where we do a long process to get the average. We do frequency times midpoint. So there are 2 extra columns in here to help us, but sometimes the exam won't provide those extra columns, so we need to know what we're doing. It says Bob asked each of 40 friends how many minutes they took to get to work. The table shows some information about his results. Write down the modal class, that is the most common class with the highest frequency. That is this one. The class itself is 20 to 30. State the class in which the median lies. Now we have 40 friends. The median is always the value that is n plus 1 over 2. So we've got 40 plus 1 over 2, which is the 20.5th value. So I think about the data. How much data have I had here? I've had 3 points up to that bit. I've got 11 up to that point, 8.3. By the time I get to the end of this class, I've had 22, the 3 plus the 8 plus the 11. And I'm looking for the 20.5th value, so it will be somewhere within this class here. So the median is also in the 20 to 30 class. Work out an estimate for the mean time taken. This is what I was talking about at the start. I kind of went ahead of myself. We've got 40 friends. The mean is therefore going to be something over 40. To find the mean, dividing each by 40. We need to estimate, so we find the midpoint of each group. We don't know these 3 people, whether they took 0 minutes or 10 minutes or somewhere in between. So we estimate that they took 5, that this lot took 15, this lot took 25. So we just find the midpoint of each class and use that. We've got 3 people with an average of 5 minutes, so 3 times 5 is 15. 8 times 15 goes in here. 120, 11 times 25 in there, it's 275, 9 times 35, 315, and 9 times 45 is 405. We then want the total of all of these times, so add them together, and that gives us 1,130. I want to take that total and divide by 40, which is also the total frequency. So always find the total frequency. It should match with the number of people mentioned in the question, and it does. It's a total of 40. Our estimate for the mean is that 1,130 divided by 40, which is a mean time of 28.25. Always look back for the units. It's minutes in here, and check that that answer makes sense for the data given. So 28.25 is kind of at the top of this category, and that works out because we can see that the data is slightly weighted towards the top end of the list because there are only 3 in the bottom category. So somewhere in the middle, 28.25 seems a sensible answer for that question. And finally, cumulative frequency graphs. So in this one, we want to add a column for cumulative frequency. Again, the exam won't always leave you with a column here ready to use. We've got the table shows the running times of some films. Draw a cumulative frequency graph on the grid to represent the data. So cumulative frequency, we want to add the frequencies as we go. By the time we get to 80 minutes, we've had none. By 100, we've had 9. 35 plus 9 is 44. Add another 30, add another 18, and add another 8, and we get to the 100. So we've got 100 films in total. With these, we want to plot the upper class boundary, which means we are saying that by the time, not the midpoint was involved in estimating the mean, and the midpoint is also involved with frequency polygons. But with cumulative frequency graphs, we want to be plotting at the upper end. So by the time we've got to 80, I've got 0. By the time we've got to 100, we've got 9. So 80 is 0, and 100 is 9, which is just underneath that. Then I've got 120 is 44. So 120, 44. And again, not in the middle of the class, but always at the upper class boundary, 120, 44. 140 is 74. And 160 is 92. 180 is 100. And we're always looking for this smooth curve from 0 frequency. So as smooth as you can, it must go through all the points. Up to the completed total frequency, total cumulative frequency there. Question 2, estimate the number of these films with a running time of less than 2.5 hours. So 2.5 hours is 120 plus 30 minutes, that is 150 minutes. So I want to find on 150 minutes here, reading up from there and reading across from there. And I've been asked running time of less than 2.5 hours, that's all of the ones down here. That is 85 films as an estimate. And question 3, the shortest film was 84 minutes long. The longest film was 179 minutes long. Use this information to draw a box plot below. So in a box plot, we know that we need the lowest and the shortest and longest time at the start and end of the box plot. So I'm going to draw in straight away 84 minutes. Now I've got to be careful because that is 90 minutes halfway through, which means that that's 84 and 88. So this line is for 84 minutes, and I'm going to draw a vertical line there. Got to make sure the scale works. And 179 minutes is 4 before 180 would be, so that's 176. So 179 minutes is literally just before the 180 line. It probably should be even further across, but it's quite hard for me to do that on here. And all of our lines should be the same height on this grid. I now need to put in the median, the lower quartile and the upper quartile in my box plot, and in order to do that I need to take them from the graph. So again, you would want to be drawing these values on the graph. I've got 100 as the total. That means that my median is going to be at 50 halfway through the data, and I want to be drawing these values on the graph, drawing these lines on the graph. I've found it quite difficult to draw that one, but I'm going to label that as it should have been right across there, which was 124. My lower quartile is going to be at 25. Which is really closer to that, so that's 114, 112. And my upper quartile is at 75, so read that off here. Anyone marking a question like this will be looking for those lines to be drawn on, and that's at around 142. So I need to put these now into my my box plot. So 112, 104, 108, 112 is here. Then 124, so 120, 124, and 142, halfway between these squares, 142. And then I want to make sure that it's clear that that's the middle of my box plot. And then I've got the syringe-like bit on here, joining my lowest point to my highest point. Of course, if you didn't have a lowest or highest value given, you would just have to use the values from the graph, 80 to 180, the values from the table. But they've actually given us 84 and 179 as our highest and lowest values. And that's it. We just want to make sure that those heights are all the same on the box plot. Okay, that's it for data handling.